First Take Math with Brian. We keep building. This is moving into our final chapters. This is kind of where it gets a little more challenging. We're going to work with what we call solving quadratic equations. It's a big word, but actually the math isn't that bad once you get used to it. A quadratic equation we've been kind of working with is ax squared plus bx plus c. It has this term here, it's very special. It's called the quadratic term. So if you see this term in a problem, it becomes a quadratic equation. The bx term is what we call the linear term, and then the c is called our constant term. The strategy we're going to be getting into for quadratics is it's going to be setting it equal to 0. Now, if you remember, we've been working with these guys, the bx plus c equals 0. Again, that was a linear equation. Linear equations, our main objective was just to get the x by itself. So we had this scale concept. We knew, since this side is 0, we had to make this side 0. But basically what we were doing is just trying to figure out what x was to make this 0. So we knew that we can zero out this 12 to start with. That gives me 3x equals then a negative 12. And then 3 times what number is negative 12. If you can't see that, you can divide each side by 3. X equals then a negative 4. So that should be our solution. So notice how if it looked like this, a linear equation, our objective was really to get that x by itself, so everything was kind of moving out of the way. A quadratic equation has more of this look. We have something times something is equal to 0. So now see how it's set equal to 0. One of our thought processes is, if you're multiplying to get 0, one of those factors must equal 0. That's very important. So if you're multiplying, there's only one way to get 0 when you multiply. One of those numbers has to be 0. So the definition you'll see in a lot of books is a times b is going to equal 0 only if a equals 0 or if b is equal to 0. So let's look at a couple examples. So I got this factor times this factor, and this has to equal 0. So our strategy is we ask ourselves, what makes this term 0? If you can see that's a 5, you're done. If you look at that one and say, what makes that 0? If you can see that's a negative 2, you're done. If you can't, what you can do is set each one of those factors equal to 0. So you can set x minus 5 equal to 0. You can set x plus 2 equal to 0. So it's got to be either this or this. So to get x by itself, we know we can 0 that 5 out. And we have x is equal to 5. To get x by itself here now, since this is now a linear equation, we 0 out the 2, and that gives me x equals then 0 and negative 2 would give me a negative 2. So my solution set here would be then a 5 and a negative 2. If I look at this one, what times what would give me 0? Well, one of these things has to be 0. Because remember, things connected by parentheses mean that you're multiplying. So what can you make x be to make this turn 0? Well, if you see that that's got to be a negative 6, and that's got to be a negative 3, you're done. Negative 6 and negative 3 are the solutions. If you cannot see that, our strategy is set each factor equal to 0. And now we have these two simple equations that we have to solve. And since this is now like linear, we just got to get this x by itself by moving that 6 out of the way. So we 0 it out with a negative 6. X equals then a negative 6. What makes this 0? Again, if we want to 0 it out, negative 3 there, negative 3 over there. Those will 0 out. X equals then a negative 3. So our solution set would be indeed a negative 6 and a negative 3 would be my solution. So stay tuned for a few more examples.